But the general idea here is that mass is not created or destroyed. So that means that all of the atoms that you have at the beginning of a chemical reaction need to be the same as all of the atoms that you have at the end of a chemical reaction. And the idea behind this is just that a chemical reaction is just rearranging atoms into a new kind of molecule or compound. And so in order for us to, in order for us to follow the law of conservation of mass, we have to do what's called balancing equations. So I have a bunch of equations here, and I'm going to do some examples, and I'll have you practice with some. And there's some rules that you can use, or some pointers, or general advice, I guess, steps that you can follow to help make it easier for you. So the first thing is you're going to balance equations by what's called inspection, which basically means you're just going to kind of look at it and see if you can match everything that's on the left-hand side with everything on the right-hand side. And the way that you do that is you're going to add what's called a coefficient. Coefficient, there you go, which is just a small whole number in front of the chemical formula. I don't know if you've had any exposure to this at all with teacher Vanessa or not, but basically you just want to go through the formulas, and you're going to go element by element and make sure that, for example, on the left-hand side, I'm going to start with sodium. And I see that there are 3 of them on the left-hand side, but on the right-hand side, there's only 1. So in order to make them even, I'm just going to put a 3 in front of NaOH. So now I've balanced sodium. One of the tricks that you can use is to actually look at, that's too, that is too opaque. I need like 25%. Okay, there we go. One of the tricks that you can do is for polyatomic ions like phosphate here. If you see phosphate, look on the other side and see if it occurs as phosphate as well. If it does, balance them as a unit. Don't look at P and O separately. If you have PO4 on both sides, you can balance PO4 as 1 unit. So on the left-hand side, you have 1 unit of PO4. On the right-hand side, you have 1 unit of PO4. So PO4 is balanced. So then the next thing I'm going to do is go back to my 3 NaOH. So once I put the 3 here, I've balanced sodium, but now I have 3 OH. And again, OH is hydroxide. So look to the left-hand side and see if OH occurs as hydroxide as an ion on the left-hand side. And it does. And you see KOH. So if I've got 3 OH on the right-hand side, I'm going to put a 3 in front of KOH. So now OH is balanced. And then now I've created 3K. I'm going to go to the right-hand side and I see that K is already 3. So once I think I've balanced everything, let me clean this up here. Get rid of that one, get rid of all that. Okay, once I think I've balanced everything, I'm just going to go back and double check element by element. So when you're balancing, you can balance the polyatomic ions as 1 unit as long as it occurs as the same unit on both sides. But once you think you're finished, then really go element by element. So starting with Na is 3 on here, Na, this 3 in front makes it 3. Next is P, there's only 1. Over here, 1. Oxygen, here's 4 plus 3 is 7. In here, oxygen, 3 plus 4, 7. And potassium, K, 3, K, 3. And finally, H, 3, H, 3. All done. If you don't want to bother going element by element, you're perfectly it's perfectly okay to balance PO4 by itself, OH by itself. But the coefficient in front acts just like in math. If you have an x plus 2 and in front of that you have a 2, the 2 counts for everything inside. So I'm going to go ahead and do a few more examples and then I'll let you do some practice, okay? So for number 2, again, balancing by inspection, a lot of these you can just kind of look at it and figure out the way it's going to go. So I'm going to start with something that looks pretty big and complicated. So I'm going to start with this one. I've got Li is 2, and I recognize CO3 as carbonate, and it occurs as carbonate on both sides. So as it stands right now, carbonate, there's 1 on each side. But lithium on the left-hand side is 2, so I need to put a 2 in front of LiF. That's going to make FB equal to 2 on the right-hand side. On the left-hand side, it is already 2. So that automatically means F is balanced. So I've balanced Li, I've balanced CO3, I've balanced F, and the last thing is Mg. And you look, here's 1, here's 1. If you need only one formula unit or one of the formulas, you can leave this blank. You do not have to put in the number 1. So I gotta go back to that 2. So that's it, finished. For number 3, there's another rule that you can put in, or not put in, but another rule you can use, which is if you have an element all by itself, balance it last. And the reason why you want to do that is because you can change the number here and here, and it only affects one element. If you start changing numbers in front of P2O3, when you change the number, not only do you change the number of phosphorus atoms, but you also change the number of oxygen atoms, and then it just gets really messy. So I'm looking at this and I'm seeing, okay, I want to start with this. And I see that there's a P2, but over here is 4. So I know that I already need a 2 in front here. So I put a 2 there. Now, how many oxygens do I have now on the right-hand side? Oh, excuse me. I have 3 here, but there's 2 of this whole thing, which means 2 times 3, which is 6. So 2 times 3 is 6. So I have 6 oxygen on the right-hand side, which means I need a 3 in front of O2. And when I think that I'm finished, I double check everything. So P on the left is 4, on the right, 2 times 2 is 4. Oxygen on the left, 3 times 2 is 6. On the right-hand side, 2 times 3 is 6. Finished. Another way that you can do it as a different shortcut. Let me go back and erase all of that. Kind of a trick. Doesn't always work, but it works most of the time. If you see something like just looking at oxygen, on one side it's 2, on the other side it's 3. Try to start with swapping the 3 and the 2. So for the O2, put a 3 in front, and for the O3, put a 2 in front. That automatically makes them both 6. And like I said, most of the time it can work out. I'm going to do 4 and 5, and then I'll give you the rest of them to do, and we'll go back and look at the answers afterwards. For number 4, first thing I'm going to do is I'm looking at the brackets, and I'm saying, okay, there's nitrate on the right-hand side, there's nitrate on the left-hand side, but I've got the bracket 2 on the outside, so that means that I need to put a 2 in front of rubidium nitrate to make it so that it's 2 nitrate. But now I've made it so that there's 2 RB. So I go to the right side to RBF and I put a 2. This 2 makes my F be equal to 2, which matches with this, and then BE is 1. So again, just double checking all of the elements. I've got 2RB, 2RB. I've got 2NO3, NO3, 2. I've got BE1, BE1, F2, F2. Okay, everything matches. And number 5, same thing. I'm going straight to NO3 first. It occurs as NO3 on the left-hand side as well. So I got to put a 2 in front of AgNO3, which means I put a 2 in front of Ag, and Cu stays as 1.